Okay, this is Professor David J. De Los Reyes. My topic for this morning already, it's past 12, will be a continuation of my long video format topic, trigonometry, and we are now on lesson number 51. We are almost done. So the subject matter for this morning will be trigonometry, lesson number 51, and this will be an example problem using the so-called tangent function. Okay, let's proceed. The subject matter for this morning will be a continuation of my subject matter long video format trigonometry, and this is now lesson number 51, and the title of the topic, the coverage. It will be a problem on the so-called tangent function. Okay, I will try to give you an example problem using the tangent function. This is almost similar to the so-called tangent law, but tangent law refers to the solution of an oblique triangle. But for this, luckily, it falls under a right triangle. So we will just be using the ordinary tangent function. It's not the tangent law per se. Okay, let's proceed. We are given a balloon, okay? A balloon. And this balloon here got a what you call this an instrument that measures the angle, okay, concerning two towns. This is town A and this is town B. The distance between town A and town B is 14.5 miles. 14.5 miles. As observed from the balloon, the angle of the first town is 29.2 degrees with respect to the plumb line. Okay, so this balloon here got a person in it, and it observes that the angle of the first town with respect to the plumb line is 29.2 degrees. For the second town, again, by using the same observer, okay, he noticed that the angle of the second town with respect to the plumb line is 51.5 degrees. Okay, so meaning to say, he observed the second town and he got a reading with respect to the plumb line of 51.5 degrees. For the first one, it is 29.2 degrees. The problem is asking how high is the balloon? How high? Okay? So as you can see it, the resulting triangle is not an oblique triangle. Oh, it's an oblique triangle, but we could subdivide it into two triangles, which will result in into two right triangles. Because if we try to drop the plumb line over here, this is the horizontal ground, this is the plumb line. When we see the plumb line, a plumb line is actually a vertical line. So meaning to say the horizontal ground. We assume that the ground is horizontal and the plumb line is vertical. So meaning to say this is a 90-degree angle and this is a 90-degree angle. So actually, the first original oblique triangle, upon dropping the plumb line, it now comprises of two right triangles. So we could use the so-called solution of this one by using the tangent function. Okay. Okay, the problem is asking what will be h equal to. How high is the balloon with respect to the ground? With the given condition, the first angle is 29.2 degrees on the first town with respect to the plumb line. And the second time, it got a reading of 51.5 degrees with respect to the plumb line for the second town. How high is the balloon? Okay, let's try to bring out the solution. We will designate the distance. There are two unknowns here. The distance between the two towns is 14.5 miles. Okay, so for the meantime, we will designate the distance of town A with respect to this point here, the drop point and the plumb line, as x. So from this point to this point, we designate that as x. So if this is x, this distance here should be 14.5 minus x. Okay? So for the meantime, we do not know the value of x. We do not know the value of h. Okay? So we must have to bring out two simultaneous equations to solve for x and h. It's either that we'll solve first for x, so we could solve for h. Okay, let's try to bring out the solution. This is now just a simple solution. By using the left right triangle, the left one, I'll cover the second one. That's the first right triangle. If this is 29.2 and this is 90 degrees, this angle here should be 90 minus 29.2, so it will become 60.8. So actually, we are having a right triangle now. This is the 90 degree. Okay, if this is 29.2, this will become 60.8. Right? This is x and this is h. Okay, it's a right triangle. This is a 90-degree angle. So the relation of h and x with respect to 60.8 degrees, we could either use the tangent or cotangent, but since our topic is under the so-called tangent function, we will use the tangent function. Tangent of this angle should be opposite side over adjacent side. So tangent of 60.8 will be h over x. Therefore, h now will be the product of x times the tangent of 60.8. Tangent of 60.8, an angle greater than 45 degrees, the tangent value is more than 1. So the value of tangent of 60.8 is 1.789 multiplied by x. We call this equation number 1. So we are now given the first equation relating h and x. Okay, so to compute for h, we must have to compute for x. For the second formulation of the equation, we will be using the right-hand side right triangle. I will cover this one, so I will bring out this one. So what will come out will be a right triangle, something like this. This is 90 degrees, right? This is h. If this is 51.5, this angle here should be 90 minus 51.5, and this will be 38.5 degrees. This angle. This 51.5 comes from the observer, okay? And this is 14.5 minus x. Okay? So the relation of h here with respect to the side, considering 38.5, it will still be tangent function. The subject matter is tangent function. So tangent of 38.5 degrees should be equal to h over 14.5 minus x. Okay, simplifying this one, h now will be the product of 14.5 minus x times tangent, or h will be equal to the tangent of 38.5. 38.5 is less than 45, so the tangent value is less than 1, and the value is actually 0.78543 times the quantity 14.5 minus x. Expanding this, it's the so-called distributive law, right? 0.79543 times 14.5 will be 11.533. 0.79543 times x will be negative 0.79543 times x. We call this equation number 2. So, after formulating equation number 1 and number 2, we are now given two equations involving two unknowns. So we solve it simultaneously to solve for h. So we equate h is equal to h using equation number 1 and 2. So the value of h using equation 1 is 1.79x, and this should be equal to the value of h using equation number 2, 11.533 minus 0.7954 times x. So after equating h is equal to h, what comes out is now just simply a linear equation involving x. So to solve for x, this is now pure algebra. We transpose this to the left. We add the coefficient 0.75943 to this. What will come out will be 2.58443x. This remains on the right, equal to 11.533. And to compute for x, we must have to eliminate this one, so we will multiply this by 1 over 2.58443. Right? We are just solving for x without this coefficient, so we must have to eliminate this. So this one here cancel with this. X now will be equal to 11.533 times 1 over this will be 11.533 divided by 2.58433. To compute for x, we use our calculator. The approximate value of x is 4.46 miles. Right? To compute for the unknown height, we could either use equation number 1 or number 2, but equation number 1 is much simpler. We now know the value of x, so using equation number 1, h now will be 1.789 times 4.46, and the approximate value is 7.983 miles, or this is approximately 8 miles. So the height of the balloon, okay, is actually approximately 8 miles. Approximately 8 miles. Okay, that's it. That's the solution of this problem here by using the tangent function. Okay, so meaning to say we brought out two right triangles, and from the first right triangle we bring out a first linear equation involving x and h, and again by using the second right triangle on the one on the right, again we formulated the second equation involving h and x again, then solve simultaneously. That's algebra. What comes out for the value of x is approximately 8 miles. Okay, that's it, guys. So for those of you who would like to subscribe to my channel or would like to watch my videos on my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. We are almost done with trigonometry. The next time around, I will be discussing the last topic that I will include in my trigonometry long video format. It's the so-called inverse function of trigonometric function. Inverse function, for the so-called sine, okay, we will take the inverse sine. So the next time around, it will be concepts of inverse functions involving all the trigo functions under the study of algebra. Okay, good morning from Los Angeles. This is Professor David J.